Hola Marta, ¿qué tal?
Hola Víctor.
Ahora,
Ya
ahora te
está emitiéndose en YouTube, ¿vale? O sea que estamos en directo también en YouTube, quiero decir.
Vale, gracias Marta.
Hola.
Hola Daniel, ¿qué tal? Buenas tardes.
¿Qué tal? Buenas tardes. Se me oye bien y todo bien, ¿no?
Sí, ya estamos también en YouTube, estamos en directo.
Vale.
Para tu conocimiento. Víctor Sebastián también está conectado.
¿Qué tal? Buenas tardes, Daniel.
Hola, buenas tardes.
Marta, ¿esperaremos un poquito sobre las 5 o hay que ser puntuales?
Vamos a dar un margen hasta a las 5 volvemos a mirar la cantidad de gente que hay conectada y damos un pequeño margen y comenzamos, ¿te parece?
Muy bien.
Vale, yo voy a ir. Claro, entonces aquí no aparece cuánta gente hay, ¿no? Ahora mismo. O somos... Estás en mute, ¿no?
Puedo decir que estamos ahora mismo, pero claro, no es la hora, 4 personas. Y 2 sois vosotros y otra soy yo.
Claro, es que por YouTube también se conecta la gente, entonces
Sí,
a veces es
sí, estará
complicado saber.
conectado.
Claro.
En YouTube hay 2 personas. Nos pueden seguir por las dos vías.
Hola, buenas tardes. Perdón.
Buenas
Buenas tardes
tardes.
por las tardes.
Buenas tardes.
Qué lío. Hola, Daniel.
Hola.
Bueno, a ver si podemos esperar un poquito, ¿verdad? Yo creo que sí.
Sí.
5 minuticos más sobre la hora igual para que hay gente que... Los 5 minutos de cortesía.
También se está retransmitiendo en el YouTube del INMA y hay un par de personas conectadas.
Supongo que has hablado con... bueno, que ya conoce que Reyes no va a poder estar, ¿verdad? Que Reyes no va a poder estar en la sesión. Reyes Vallada porque tenía clases hoy con los estudiantes. Pues no sé si... Víctor sí que está, ¿verdad? Sí. Ahí
Sí.
está. Bueno, no sé si presentarnos formalmente o qué, porque no nos conocemos, igual nos podemos presentar. Estamos todos en el mismo grupo de,
Sí.
bueno, creo que conoces, ¿no? Por lo que conoces del ciber, bueno, estamos en el grupo que lidera Jesús Santamaría. Creo que en mi caso yo no te conozco de reuniones previas y bueno, soy profe del Departamento de Ingeniería Química y ves el loguito del INMA porque ahora estoy en la subdirección del Instituto de Nanociencia y Materiales. Pero vamos, vengo aquí en concepto de oyente como para aprender.
Bueno, yo soy ingeniero químico, no sé si lo sabes.
Sí. Le pasé claro, es que también estoy coordinando el máster en nanociencia y materiales
Sí.
y les pasé el enlace de la charla. Obviamente lo que pasa es que ahora están en clases, un grupo está en prácticas y no creo que puedan entrar, ¿eh? Están avisados y también es, como se graban las charlas en YouTube, yo creo que ellos se organizan un poco, ahora están apurados con el TFM y demás. Y eso está muy bien porque luego ya la pueden visualizar obviamente la charla sería mucho más dinámica si hubiera más audiencia, ¿no? A ver si conseguimos.
En mi caso, Dani también soy compañero de Pilar del mismo departamento de Ingeniería Química y coordino además el grado de Ingeniería Química y que también disemine un poco la charla. Lo que pasa es que también es un horario donde también hay clases, entonces a veces es complicado. Los estudiantes ahora en qué cursos también están o bien de forma presencial o de forma telemática, entonces pues claro, tener dos clases o dos videoconferencias a la vez es complicado. Así que bueno, no sé si aunque sea YouTube, a posteriori podrán seguir la charla. De cualquier manera, estamos encantados de tenerte aquí con nosotros.
Gracias.
Sí, bueno, yo soy Marta, ya me conoces que hemos hablado, que estoy en la cátedra y yo me imagino que lo que más visualización va a tener es la grabación de la charla en YouTube. Y porque se queda grabado tanto en el YouTube del INMA como de la propia cátedra. Y luego sí que hemos hecho estudios de visualizaciones y los interesados suelen ir a la charla ya grabada. Entonces tampoco nos vamos a poner muy tristes porque no haya mucho quórum ahora, porque es que luego estará accesible y es donde realmente se visualiza. Si os parece, esperamos un par de minutitos y comenzamos.
Sí. Por mí no hay problema.
Ya se van incorporando, personas. Hola, buenas tardes. Buenas tardes, Teresa.
Hola, buenas.
Hola.
Víctor, si quieres comenzamos ya y yo voy añadiendo a las personas que se vayan incorporando, ¿vale?
Muy bien, perfecto. So welcome to this Thursday spin-off talks. My name is Víctor Sebastián. I am associate professor at the University of Zaragoza in the Department of Chemical Engineering. So today it's our pleasure just to getting with us Daniel Pando, which is also a chemical engineer. He is the CEO of the spin-off company Sanovest Biotechnology. Daniel, who got chemical engineering degree at the University of Oviedo, and then he did the PhD in the drug delivery systems and the application of these drug delivery systems in nanobiomedicine. After the degree, he got to the University of Cagliari in Italy, and he specialized in the design and applications of these data delivery systems. So after that, together with Rebecca Alonso, they co-found the Nano spin-off, Nanovex Biotechnology, and this company, as she will tell us now, it's specialized in the production of different, a wide variety of nanosystems, usually for drug delivery applications and cosmetic applications. So then it's our honor just to get in with Daniel here with us. The floor is yours. Just for those that are in the Zoom, please get your microphones mute until the end of the lecture. And then once Daniel conclude the lecture, you are welcome just to unmute the microphone and just give your questions, ask your questions to Daniel as much as you can. So then, Daniel, thanks for getting with us today. And also, thanks to the Cátedra SAMCA de Nanotecnología de la Universidad de Zaragoza to support these conferences. Thanks.
Thank you for the invitation. I'm going to share the screen. Okay, can you see the screen?
Yes.
Yes, yes.
Okay. If anybody have some question at any time, she or he can ask me without problem. Okay. So I'm going to introduce you our company, Nanovex. This presentation is divided in 3 parts. The first part is a corporative dossier. Okay. In this part, I am going to talk about the company, and the other 2 parts are divided in a part for Nanovex, is the medical application company, and the other one is Indermal, that it's the cosmetic brand. Okay, so Nanovex, it's a company founded in 2014, at the end of 2014, with the participation of Química del Nalón, an international company of here in Asturias. In these almost 7 years, we have won several awards, okay, that endorse our trajectory. For example, the CEEA Awards and the Norway's Investors Day Award. And at first, our business was focused on medical applications, okay? But as I told you before, then we create another business line, cosmetic line. Here is a brief presentation of our partner, okay? Química del Nalón is a company that it is more than 77 years old, okay? And it forms part of a very big group of other companies, okay? And that this group is more than 100 years old. Química del Nalón has an turnover around 200 millions of euros. And at this moment, he has the 51% of the company, of Nanovex. Okay, now our mission and our vision are very similar. Our mission is to develop and manufacture innovative products using nanobiotechnological tools, okay, mainly drug delivery system, for improve the people's life, okay? And our vision is to be a benchmark company in this drug delivery market. Our strategy is to have a growth sustainable, okay? And for this reason, we are growing step by step. And our values are the honesty and compromise, and for me, the best important is the scientific rigor. where you can find us. Nanovex is present in several countries, okay? But our main customers are located in the United States and Europe. And Indermal is also, Indermal has customers around the world too, but our main customers are in United States and Europe too. Okay, this is what I told before, the two parts of our company. A brief resume of one of them, Nanovex, drug delivery systems for medical applications. We can develop different drug delivery systems, such as PLGA nanoparticles, nanovesicles, synthetic exosomes, metallic nanoparticles. And in Indermal, we use this drug delivery technology, the same in Nanovex, but apply it to cosmetic. At Indermal, we have developed a different drug delivery system focused on the target. In this case, the target layers of the skin or other structures, such as the hair or the follicle. So in this way, we can develop specific systems for delivery of the cosmetic actives and improve the efficiency a lot. Okay, now I'm going to introduce in more detail Nanovex. Nanovex, in Nanovex, we develop drug delivery systems to encapsulate drugs, okay? And although we have several customers with several applications, I think that we are specialized in three treatments: vaccines, cancer diseases, and central nervous diseases. So we have, although we work in other fields. Our technology is based off nanovesicles, although we can perform as well PLGA nanoparticles. And in these systems, we can encapsulate a lot of actives, such as drugs, peptides, proteins, or genetic material. And from COVID, to be honest, we work a lot with RNA. So in this way, we have different projects at this moment with Spanish and European companies that produce RNA, mainly for vaccines, but we are working a lot in this field because, as you probably know, this genetic material needs to be encapsulated also in the COVID vaccines in order to avoid degradation and to deliver it in the target cells. So we are working a lot in this sense. And in the cancer cells, we work, the main advantage of this technology is to encapsulate the drug and make a targeted delivery in the cancer cell. As you can see in this picture, there are different delivery strategies, okay, but maybe the most important is the intracellular delivery, in which these nanovesicles are able to be endocytated by the cell and able to deliver their encapsulated compound inside. This has two advantages. The first one is the capacity to increase the efficiency of the treatment, sometimes 10 times more. And on the other hand, this technology leads to less collateral effects of the drugs, because the drug is only working in the target, but no in other places. And in the brain, in the central nervous system diseases, the target is the brain, and these drug delivery systems are able to cross the brain-blood barrier. So these nanovesicles are able to reach the brain and deliver there the encapsulated drug. We use different drug delivery systems for these applications. Mainly, the most important are the nanovesicles and the polymeric nanoparticles or nanovesicles. In nanovesicles, the most important systems are liposomes, okay? Sometimes people think that liposomes is only one kind of nanovesicle. Liposome is a nanovesicle based on phospholipids, but you can perform probably 100,000 of different liposomes because you can change the phospholipids, you can add some stabilizers or other compounds like surfactants. So you can really do very different liposomes. Okay, so our favorite system is liposomes. Although some customers want to perform polymeric nanoparticles, PDAG, and then there are other customers very focused on exosomes, synthetic exosomes. In addition, we also develop metallic nanoparticles. Sometimes it's not very common, but sometimes these nanoparticles can be used in drug delivery because they are not able to encapsulate compounds inside, but you can modify the surface of these nanoparticles with drugs or with proteins. And in addition, these nanoparticles are used in diagnostics. In recent years, there is a new line of research that combine the diagnostics and the treatment. The name is theranostics. In this in theranostics, this field use systems that are able to deliver the drug into the target, and at the same time, you can make the diagnostic of diseases. For example, if you have a nanovesicle, a fluorescent nanovesicle with a drug encapsulated inside, and this nanovesicle is go to this target place, you are doing at the same time the treatment of the disease because the nanovesicles are delivering the compound into the target, and at the same time, as they are fluorescent, you can, if the nanovesicle reached the target, it implies that there is a disease and you can make the diagnostic at the same time. This theranostics application can be performed as well with these metallic nanoparticles. Okay, so you can make different approaches or different applications with these drug delivery systems. So we can divide in 4 different strategies. The first one is the targeted drug delivery. This is what I'm told right now, is a surface modification of the nanovesicles using antibodies, and that in a way that they can reach and specifically deliver the content into the nanovesicle in a specific cell, because in this cell, in the surface of this cell, there is an antigen that recognizes specifically the antibody of this nanovesicle. So when the nanovesicle with this antibody reaches the antigen of the cell, the nanovesicle is endocytized inside the cell and deliver the compounds there. The second one most used strategy is the fluorescent. Okay, of course, all of these strategies can be combined, so we can have a targeted drug delivery system and fluorescent at the same time. This is for theranostics applications. The fluorescent nanovesicles are made of normal liposomes or metallic or fluorescent nanoparticles, or polymeric nanoparticles, in which we add, using a covalent bond, a mark, a label, a fluorescent label. And then other interesting strategies are the controlled release, that in this strategy we can control the release of the encapsulated drug with different parameters. For example, we can perform nanovesicles that deliver the compound at a specific temperature or in a specific pH, or even in when the nanovesicles when the nanovesicles is exposed to the light, for example, so we can control the release. And other strategies are based on make surface coatings that this surface coating leads to a specific delivery, to specific strategies. For example, when you use pegylated nanovesicles, for example, COVID patients use these pegylated nanovesicles. This is for a longer delivery in the body because this PEG avoid the removing of the nanovesicles by the body. So we can also offer different services. For example, the characterization. We perform here a lot of different characterization of bioparticles. The most important is the size and distribution, the zeta potential, in order to measure the electric surface of electric charge in the surface of the nanovesicle. We can also perform measurements of the nanoparticle concentration in different media, and morphology analysis in order to see, for example, if a nanovesicle, the morphology or how many layers it has, among others. And of course, we can perform heat, drug loading, and entrainment efficiency in order to know how much drug is encapsulated inside. How we work with customers. I'm going to move. Okay, sorry. When a customer comes to us in order to work with our technology, and in order to meet the requirements of the customer, we need a lot of information from him. So the first part is to make a technical consulting in order to know all the information of the drug that they want to encapsulate, the diseases or the treatment that they want to carry out. And when we have all this information, we are able to send them a quotation in order to start to work. Of course, in Nanovex, we have two different types of customers: university and research centers and pharma companies. In recent years, we have more pharma companies as customers than universities. And with this customer, of course, the confidentiality is very, very important. So the projects also always start with the scene of a confidentiality agreement in order to make these customers confidence. Then we make a work proposal and start to work in this drug delivery system specifically designed for the customer. We perform different proof of concepts or prototypes, so they can test in different, sometimes in mice, in performing in vitro assays. It depends. At this moment, we have probably 50 or 60% of our work are based in genetic material encapsulation, because I think that from the development of COVID vaccines, I don't know how many companies, but probably more than 50% of the pharma companies are trying to use this technology in his applications. So we have performing new vaccines, and for example, we have performing from 2-3 months ago new ocular treatments using as well RNA, this genetic material, and we are going to start another project using RNA for dermal applications. It's not very... Our experience. We have, in brief, we have in Nanovex experience encapsulated compounds performing surface modifications using both antibodies, proteins in general, and polymers. Okay. Targets, I mean that we can perform targeted delivery. Targeted delivery is not always, but almost always performed using antibodies in the or proteins in the surface of the nanovesicles in order to the nanovesicle specifically recognize the antigen. We have performed very different nanovesicles for a lot of applications. We have performed new treatments, or we have to help to perform new treatments for diseases in the liver, in lungs, in the brain, in the skin, in the colon, in very different applications, and very different administration ways. The most typical in this application is using injections in the intravenous way, because although the nanovesicles, the drug delivery systems, one of these advantages is avoid injectables. For example, when you want when you need, for example, nicotine, now it is very known that this patch, in the skin patch, in order to make a delivery through the skin, transdermal delivery of drugs using these systems instead of injections or oral applications. But when the aim of the work is to reach a specific organ or a specific cell, you have to use this intravenous way in the most of the cases. And now I'm going to talk about indermal. Although maybe this application is probably less interesting than the medical application. Currently, the 90% of the turnover, the invoicing of the company is because indermal. The history of indermal is in 2017, 3 years later, or after 3 years of life of the company, and because several cosmetic companies ask us about the possibility to encapsulate cosmetic actives. They ask about if you can encapsulate a drug or a protein, can you encapsulate a vitamin or retinol in these systems? We thought about the possibility. We make a market study, and we realized that there are not too much companies, liposome or drug delivery companies in the cosmetic market, and although you can find some company similar to us, to be honest, the technology is not very I don't know how to say that, but it's not the best. Okay, so we thought that we have a very good opportunity to get into this market and to show to these companies that we have a technology applied, the same technology that we use in medical applications. We can use this technology for cosmetic applications. So we develop using the know-how or expertise in drug delivery systems for medical applications. We perform an drug delivery system for cosmeceutical applications. We have some experience in this field in skin, okay, because I did a part of my PhD thesis in Italy working with skin, and in Nanovex we have different projects for dermal applications, so it was not very new for us, but it was very important to make a specific delivery system for cosmetic, because the cosmetic application, when you use a drug delivery system for cosmetic application, the delivery must end in the epidermis. It is very important and not pass through the epidermis, because if a compound passes through the epidermis, you are talking about a drug, a pharma. And if you are talking about cosmetic, it's very important to stop the delivery in the epidermis. So we develop specific types of liposomes able to deliver the encapsulated compound in different layers. In the epidermis, most of the cosmetic actives must be delivered in the epidermis, vitamin C, retinol, in the corneum or in the top layer of the skin. Okay, there are some compounds that must be delivered there in the surface of the skin. We developed, this is the new one, the newest, a follicular delivery system. This is very used for some hair products in order to avoid the loss of the hair, and a hair delivery system. And you know, because probably most of you are use cosmetic products, that now it is very common to find vegan options of all these products. So we have also a vegan option, or a vegan nanovesicle for all these applications. The most important system regarding the application of the number of products is DDS, that means Deep Delivery System. These nanovesicles are developed in order to deliver different compounds in the epidermis. In the epidermis is where are located the most important cells, such as melanocytes, Langerhans cells, etc. This system is ideal for despigmentation substance, antioxidants, anti-wrinkle, anti-aging in general. So, for example, you can see at the bottom of the screen a picture. This is some penetration studies that we perform using confocal microscopy. In this case, we use, if you remember in the part of Nanovex that we are able to perform fluorescent nanovesicles, this is the same. Here, we perform fluorescent liposomes using rhodamine, a red fluorescent compound, labeled into the liposomes. So we put these liposomes on the skin, and after 8 hours, we carry the skin to the confocal microscopy in order to track or to see where the liposomes are. And we found that liposomes are able to reach the epidermis, as you can see in the picture. So it means that they are able to deliver the compound into the epidermis. The second system is the CDS, the corneum delivery system. This is specifically designed to make superficial layer delivery. Normally, this system are used for renovators or anti-acne agents, peeling treatments, and now it is very used for encapsulation of different acids. Okay, because in addition to all the benefits of the encapsulation that are a protection of the encapsulated compound, make a specific delivery in a specific layer, other important advantage or benefit is that, for example, when a customer asks about use some acid, for example, glycolic acid is very used now into a cosmetic product. If you put an acid in a cream that the pH of the cream is 6 or 5.5, the most of this acid is turned in the salt. So really you don't have the acid, you have the salt. So the product is not very efficient. So another advantage of this system is the possibility to encapsulate this acid in a very low pH, for example, pH 3, to be sure that the acid remains in the acid form, and then you can add this liposome into a cosmetic product and at other pH, for example, 5 or 6, but inside of the liposome the pH will be 3. So when the liposome delivers the acid will be in the acid form. So this other option to you, or other advantage of using liposomes. In that case, in the 3DS liposomes, here you can see in the confocal microscopy how the liposomes reach and deliver the compound into the top layer of the skin, stratum corneum, and the liposomes don't penetrate too much in the skin. This is the newest system, the FDS, follicular delivery system. 95% of the customers that buy these products or that they have interest in this delivery system is in order to manufacture anti-hair loss agents. The same of the other studies you can see here. In the penetration study using confocal microscopy, how the liposomes reach the follicle and they are concentrated into the follicle. Of course, that leads to a very efficient treatment. And the last one is the hair delivery system. This is all of these systems are based on liposomes, but of course all the liposomes are different. All liposomes are based on phospholipids, but depending on the application, for example, hair delivery or follicular delivery or dermal delivery, all of them have different phospholipids and have different stabilizers and other surfactants. And then in each delivery system, for example, in this HDS delivery system, all the products have as well different formulations, okay? Because not only the formulation not only depends on the target delivery, but it also depends on the compound to encapsulate. So although we have a DDS system for the delivery system, it has different formulation if we are going to encapsulate retinol or if we are going to encapsulate a vitamin. In the hair delivery system, you can see in this micrographs how liposomes are able to adhere to the hair in high concentration levels and can resist washing and raising. Here we are going to talk about the main advantage of these systems. Okay, the first one is in order you are able to perform a smart delivery strategy in order to, you can deliver the encapsulated compound to a specific layer of the skin or the hair or follicle. You have a complete protection of the encapsulated active. This is very important because a lot of compounds used in the cosmetic market are antioxidants. That means that it is very easy to oxidation. or are easy to degrade, or they are you have to avoid the solar radiation because they are photosensible. For different reasons, this is very important to perform a protection of the encapsulated compound. That also means a higher efficiency, because if you have a specific delivery system, and in addition you are sure that all the product that you are delivering in the specific layer is in the active form, in the correct form, the efficiency increases a lot. These liposomes are very resistant. They can resist temperatures close to 78 degrees and shear stress up to 20,000 RPMs. And they can resist as well different pH ranges, because sometimes different hair products can have a very high pH, around 11. We always talk about our liposomes have a biomimetic composition because we use the same or very similar phospholipids regarding the phospholipids that you can find in the cell membranes in the skin, and we also use cholesterol as membrane stabilizer. In our cells, we have cholesterol that plays the same role. And we use other compounds like mannitol that plays a role very similar to some glycoproteins. So we always talk about biomimetic composition of our liposomes. And the liposomes have the ability by themselves to repair and to restore the skin, although they are empty. In the cosmetic field, the people demands data in order to be confident or to be sure about the technology that you are offered. So we offer quality and reliability of all our products, because all of our products have efficiency tests. Here you can see as example at Indermal, we perform two different efficiency tests. Here in the company, in our devices, in our facilities, we perform the skin delivery, skin penetration studies. We use pig skin and we compare a free compound, for example, in this case is retinol. We make a comparison between free retinol and encapsulated retinol, and we study how much the encapsulated retinol, how much improve the penetration in the skin. You can see here that, of course, the experiments are performing in the same conditions, same temperature, same concentration of retinol, all is the same. And you can see here that retinol, when retinol is in his encapsulated form, the delivery of retinol into the epidermis, that is the target layer, increased 1,150% in comparison with free retinol. In this case, the active was retinol palmitate, a very stable form of retinol. So the increase of the efficiency is very, very important in this case. 1,150% of increase in the delivering is not very easy to reach. Another important characteristic of these systems is that although we are always talking about nanovesicles, nanomaterials, this is not a nanomaterial regarding the cosmetic rules, because in order to be a nanomaterial, for being a nanomaterial, a particle must be lower than 100 nanometers, the first thing, and it must be not biodegradable, are not soluble in the body. So a compound must have these three characteristics to be a nanomaterial. Our liposomes are higher than 100 nanometers. It is around in a range of between 150 and 300 nanometers, but although it was lower than 100 nanometers, there will be not a nanomaterial because liposomes are biodegradable, are soluble. So this is very important for the cosmetic companies to be sure that this technology is not a nanomaterial. Nanomaterials are not forbidden in cosmetic, but the use of nanomaterials in cosmetic implies a communication to the European Committee, and you have to perform several experiments in order to be sure that there is no danger for the health. For example, now there is other similar technology that use metallic nanoparticles for sunscreen, sun protection, and in order to avoid in order to avoid to be a nanomaterial, although the core, the nanoparticle, is lower than 100 nanometers. Often they has 50 or 60 nanometers nanomaterials. This is the core of the nanoparticle, and then people start to put on the surface of these nanomaterials different polymers in order to increase the size of the nanoparticle and to be above the 100 nanometers. So when we offer all this information to the customers, they ask about, because all these experiments, the skin penetration experiments, are performed here in our facilities. So we thought that it will be a great idea if we work with an independent lab in order to perform some different studies. So we start to work with other independent laboratory in order to perform other efficiency tests. Here you can see the efficiency test of our product. The name is DDS kojic. This is kojic acid, a very good disinfectant. And in this test, we make a comparison between kojic acid encapsulate and kojic acid free. We use human skin explants to simulate real life situations, and this skin is irradiated with UV, and when skin is irradiated, the melanin levels start to increase, and then in these irradiated controls, we apply the free active and the encapsulated active. And after a week, I think, we check the melanin levels on the skin, and we found that when kojic encapsulated product is used, the melanin levels almost reach the control levels, but in the kojic acid, the free form, the melanin levels decrease very a little, only a little. It is hardly appreciable. So, and this is one example of the power of the delivery systems in cosmetic. Because this system is able to deliver the kojic acid into the epidermis where the melanocytes are. Here you can see the test of the retinol or bestseller. And in this case, we perform a similar test, but in this case, we are focused on the collagen. We have a human skin as well, control, and the skin is aged using corticoids. When the skin is aged, the collagen concentration in the skin start to decrease. So when once we have this aged skin, we put on the skin the free form of retinol and the encapsulated form of the same retinol. Here, maybe it drives to confuse, because here it puts retinol and here it puts retinol palmitate. In both cases are retinol palmitate, same concentration and same characteristics. The only difference is the encapsulation. And after 7 days of treatment, the measurement of the collagen concentration was performed, and here you can see how in the encapsulated retinol product the collagen levels increase a lot. So using this product, you are able to recover 90% of lost collagen in the aging process. So this is, in words of the person in charge of perform this experiment, it was the best result that they test, or that they saw performing this kind of tests. And finally, here you can see different products that we have in our portfolio. Most of them are very known because we encapsulate the most known or the most used compounds. And we have a custom development system or service, sorry, and that we use a lot overall in big companies. We use these services in order to develop specific liposomes containing specific actives for cosmetic industries. For example, if a cosmetic company come to us and they ask about, I don't know, a specific compound that we have not in this portfolio, or they have his own active, we can develop specific liposomes for them. And we also help to these customers to carry out an industrial protection, like a patent, in order to make or to have high value products, because they use then this patent of this industrial protection as a marketing tool. So that's all. Here you can see our the contact Nanovex in dermal, and Química del Nalón, that is a partner of us, the most important partner. And now, if you have any question, I will be glad to answer you.
Okay, thank you, Daniel. In fact, it was a very inspiring lecture. You give us a clear overview about the great variety of nanosystems that Nanovex can produce, which is quite interesting because some of us are also working in this field, the field of drug delivery. So it's quite interesting just to know how companies are dealing with these kind of systems. So I have plenty of questions, but first I prefer just to open the floor to the audience and then try to discuss with you as many questions as they have. And if not, I will ask you some questions. So please, you are welcome to unmute your microphone and tell us.
No too much questions.
Okay, so then maybe it's better just I will start and maybe someone else can ask later on. So the first question, Daniel, is that I'm sure that you have an R&D department just to work on these new formulations. So how difficult is for the company just to translate the production from the lab to the big production? Because sometimes it's difficult to reproduce the processes. So I don't know if you can share with us some knowledge about how difficult or how easy it is to do this transfer.
Yes, no, easy is not easy. It's
Okay.
it's hard. In order to because for me it's a very interesting information. The first year, not the first year, because the company was founded at the end of 2014. So the first year we did not too much things, but the second year in 2015, maybe in total all the year we produced around 5 kilograms of liposomes, because our main customers are research centers, universities, and pharma companies that use a very small amounts of product in order to perform tests, in vivo tests, in vitro tests. As you know, like me, that in this kind of test, you don't need a lot of too much amount of product to perform. So the first years we can manufacture it, yes, around 4 or 5 kilograms. This year, today, at the end of April 2021, we have produced more than 4 tons of liposomes. So the way from 4 or 5 kilograms per year to this year that we are going to produce almost 10 tons of liposomes, it was not very easy. In the lab, we have different devices to produce nanovesicles, and sometimes it's very hard to produce nanovesicles in very small volumes, because, for example, when a customer wants to encapsulate very specific compounds that they are very, very expensive, you cannot offer more than 1 or 2 milliliters. So sometimes it's very hard as well to produce very small volumes. But here we have the most common techniques: homogenizers, sonicators, and microfluidic devices. The demand start to increase. Indermal is a company that offers these solutions, these products to cosmetic companies. So the orders start to increase in number and in amount. So we develop a pilot reactor, not too big, around 10 liters of volume. And with this reactor, we started to produce the first industrial liposomes, but the formulation is the same, because, as I told you in the first or the second slide, for us, the scientific rigor is the most important value. Okay, you will have the same liposomes independent of you as about 1 milliliter or 1,000 kilograms. It's the same formulation, the same procedure. And with this reactor, we reached around the productions around 10 or 20 kilograms per day. And that year, we reached around 400 or 500 kilograms of liposomes. At this moment, we have 3 reactors, and we have a production capacity around 220 kilograms per day. But I want to highlight that the formulation and of course, in other volume, but the fabrication steps are the same in higher or lower volumes. And of course, you need money to perform this growth. But normally it's not a problem. Go to your partners or to investors in order to get money when the problem is that you are growing. So normally it's not a problem. The problem is when you ask about money to survive. In that case, we need the money because we have a very big demand, and it was not a problem to get this money. today we can finance of these devices with our benefits, and we are located in a building with other startups, and now we realize that this is not our place because we are in a second floor, and here every day comes kilograms of raw materials, and we are looking for move to other place more adequate for our activity.
Okay, thank you, Daniel, for the achievement. It's quite interesting, these numbers. I believe that one of the persons, Pilar Pina, were interested in just make a question. So please, Pilar.
Thanks for the presentation, Daniel. I think it was quite clear. Yes, I was really surprised with the numbers. Yes, congratulations for the situation, because it's really good news. And I am afraid about the difference between, as I understand, the cosmetics market. I mean, at the end, you increase a lot the production of these dermocosmetics, and this is due to all the regulations that Vesicle has to fulfill when it's used for cosmetics, are less, let's say, restricted, or even for medical applications, because you are not working in the nano scales. The regulations are like, let's say, smoother.
Yeah. No, in cosmetic field, the regulation is smooth in comparison with medical applications, of course. For example, in time, if we measure the development in time, when we are talking about a drug development, okay, in the COVID case, it was 1 or 2 years because it was a exceptional case, but normally it takes around 10 or 15 years from the lab to the market. In the cosmetic field, it depends of the company. In these 4 years in Indermal, we found companies that are able to develop a cosmetic product in a few months, 3-4 months. But on the other hand, there are companies that takes more than 2 years in develop a product company. It depends of for example, there are companies that for me, the best companies that takes a lot of time in testing the products, in performing different in vitro, in vivo assays, and there are other companies that they are not performing a lot of tests, only the mandatory test, and they are able to perform these products in a few months. And then the regulation, of course, is not the same. Here in Europe, we have a list of forbidden products, but if you develop a product with the normal compounds, use it in cosmetic formulation, we use normal compounds, phospholipids, lipids. For us, we are a raw materials product manufacturer, not a cosmetic company, but for us, we have not to make to notify to the European Committee nothing. It is very much easier in the cosmetic field than in the pharma. In addition to the facilities to produce, of course, here we have one production lab to perform liposomes. We meet the requirements of the cosmetic laws, although we are not a cosmetic manufacturer. But of course, to produce drugs or EPIs, you need a clean room. That if we are talking about probably more than 1 million euros to turn a normal production room in a clean room to produce this kind of drugs. So although in our vision, Our vision is to turn this company in the medical field from a research and development company to a manufacture company in the drug applications, in the pharma applications. Now we are focused on the cosmetic field because we have had, yes, I think that we have had a successful trajectory in these 4 years. And I think that it was because we offer a very, very transparent technology. I mean that it is easily demonstrable to the customers our technology because they can see our formulation or manufacture methods or results, the characterization, the results of the efficiency studies, and the companies of the competitors.
Very far away from you.
Yeah, yes, they not offer any data about the liposomes. You can see that, for example, the rest of the companies that produce liposomes for cosmetic applications, they always use lecithins. If you use lecithin, as you know, is a mix of a lot of phospholipids, very different, with fatty acids. It is impossible to control because we control the delivery, the specific delivery of the systems by changing some phospholipids for hydrogenated or not hydrogenated, or the length of the chain. So this is very easy to explain to the customers. So now we are known as a company in the cosmetic field, as a scientific company that really produce very high quality liposomes. So I think that this is the reason of this trajectory.
And also, Daniel, I think Victor asked you about the reactor sizing right now. You increased to the pilot plan, but how about the yield? How about the conversion? Or how, from a chemical engineering point of view, if you want to make like this sustainable analysis, you are able to convert all the
yes. It was not very difficult, but yes, we have to we work not alone, of course. We work with an engineer from Chemical Alone, the engineering department of there, and a company that they are experts in the manufacturing of this kind of reactors. But we have a very specific method. We have our own method to produce liposomes, and we have to change. The reactor is a specific reactor for us. We have to change some things of the design of the reactor in order to meet our requirements. At this moment, we have the reactor 10 liters, other one of 50 liters, and the best and the bigger is of 100 liters. And yes, we have. It was designed for us in the most part of the reactor.
Okay.
So any other question? Okay, I will say, Daniel, it was interesting to me what you mentioned about the strategies that companies follow just to bypass these regulations about the nano feed. As it was written in your slide. I'm curious about if the size is important for the skin penetration efficiency, because for sure to avoid the regulation you need to work over 100 nanometer size. But I'm not sure if you decrease the size of these vesicles, if you could even improve the delivery of the drug through the skin. So I don't know at the end what is the best just to balance to skip the regulation, or just to improve even more the delivery in the skin.
Regarding
what do you think about that?
Yeah, regarding the regulation, this kind of systems, liposomes or other nanovesicles, they are not nanomaterials even you are lower than 100 nanometers because the formulation is biodegradable and insoluble. Okay, so although you are lower than 100 nanometers, you have no problems regarding the nanomaterial terms in cosmetic field. For example, I always put the same example, a protein. A protein is lower than 100 nanometers, but it's not a nanomaterial because it's biodegradable and soluble in the body. So for this reason, these kind of systems are not nanomaterials, even you are lower than 100 nanometers. But for example, if you use metallic nanoparticles, okay, that they are used in cosmetic because they are a great sunscreen technology. If you are lower than 100 nanometers, you have a nanomaterial, okay? In any case, there is it is not forbidden, but you have to put money to test the security of the product. But although nanomaterial terms are not a problem regarding regulation, there is another problem that you cannot go through the skin. The delivery must stop into the epidermis because a cosmetic product is a product that only works in the top surface of the skin. If you reach the dermis, you can have a systematic a systematic effect. Okay, so when a customer asks about a system that reach with very high efficiency the epidermis, you have to reduce the size of the liposomes, but you have to pay attention not to cross this barrier, the epidermis. I don't know if in English is the same expression, but all of them are Spanish. We always say that the equal solve to the equal. So if we bring this sentence and use this sentence in our work, when we want to deliver in a specific layer, we always use a formulation very similar to those lipids or compounds that you can find in this layer. For example, when we want to perform a very, very top, I mean that in the surface of the skin, delivery, we normally use ceramides and other lipids that you can find in this layer. When we want to make a deeper delivery, we use compounds that you will find in these deeper layers. And when we want to carry out a deep delivery, we use as well penetration enhancers and edge activators that make liposomes more flexible, and it is easy for them to reach this layer, because to reduce a lot the size can lead to the problem to cross the epidermis.
Mm-hmm.
Thank you. Any question?
No question in YouTube.
Okay, so let me my last question, Daniel.
All the questions you want.
I'm just curious. In fact, exosomes are made of lipids. So at the end, I'm not sure what is the difference between the liposome and a synthetic exosome, because more or less should be similar, right?
Yeah. The synthetic exosomes are used for scientists that are performing some technique in order to measure or to detect exosomes, and sometimes it's very expensive for them to concentrate or to separate in order to get natural exosomes. Sometimes the only thing that they need is a vesicle that in the surface has a specific protein. In the case of exosomes, the most known proteins are CD9, CD61, and CD93. So for them, it is easy easy and cheaper to buy synthetic exosomes that are liposomes that in the surface have these proteins that to get a sample of a human sample, purify the sample in order to get the exosomes, and then to purify exosomes from other exosomes in order to reach or to obtain those specific exosomes that you need. So, for example, for diagnostics, you only need a nanomaterial, a sphere, the same size of an exosome, the same composition. Exosomes are formed as well by phospholipids. And in this case, it's very, I think that it's a very easy tool, a cheap tool to use synthetic exosomes because they are very, very similar. This is the only application of these synthetic exosomes, I think. Sometimes you can use this, you know that exosomes are one of these, the work of the exosomes are the communication between cells. So we have some customers that use synthetic exosomes, like drug delivery systems, like carriers, in order to transfer some components between cells. But 95% of our customers that use synthetic exosomes is in order to diagnostics or similar techniques, and to avoid to purify or to buy natural exosomes that they are very expensive.
Okay, that's interesting. Sí, please, Pilar.
Yes, yes. Just the last one from my side. When you was explaining the skin penetration test, Daniel, you always compare with the drug with the
free drug with the encapsulated one.
Yeah. But my question is, which is the amount of the encapsulated drug that is released? Or at the end, you release all the cargo? I mean, maybe.
Yes. I think that I got the question. The experiments are performed with 100 microliters of sample in both cases that contains 3% of free drug and encapsulated drug. In terms of how much drug is released in each layer, in both cases, the most of the drug or the active remains in the surface of the skin, because in the surface of the skin we have a barrier, natural barrier, that don't allow to penetrate to other compounds. So in both cases, the most of the compound still remains in the surface of the skin after 8 hours, but maybe in the free drug is 99%, and in the encapsulated drug is 85%. So this difference, 50%, is the difference that makes the difference regarding the efficiency, because this 50% is able to cross the skin and to deliver into the epidermis. Maybe, of course, skin penetration tests here in the lab. We perform these experiments using pig skin, is a dead skin, so we cannot extend a lot the experiments. The maximum is 8 hours. Maybe if we in cosmetic we have other with our independent labs, other experiments with people that takes more days. But regarding these skin experiments, maybe if we are able to extend the skin penetration test for days, probably we can reach that. I don't know if all, but almost all of the drug go into the skin. But at 8 hours, in the encapsulated drug penetrates only 50% more or less, and in the free drug at much 1 or 2%.
Okay.
I mean that also you can see, let me show you here. Here, you see a very great difference between the encapsulated drug and the free drug. But here you can see, it's not easy to see, micrograms, 5 micrograms per square centimeter. Okay, this is the amount of retinol in the encapsulated product, and the amount of retinol in the free product is around, I think that less than 1 micrograms of retinol per square centimeter. I mean that although this difference is very important, the total amount, 5 micrograms and 1 microgram, is a very small part of the total that we put on the skin. Okay, but in the free retinol, nothing penetrates into the skin, a very, very small percentage at 8 hours. And in the encapsulated drug, a very small amount is able to penetrate at 8 hours and to reach the retinol.
Okay.
This is because our barrier in the skin works very, very, very well.
Yeah.
Luckily.
Yeah. Right. Thank you. Understood.
Okay, so I don't know if there is any other questions for the audience.
Yes, sorry, in order a detail. In these skin experiments, we have a collaboration with the hospital of Getafe, that they are all provider of skin because they perform there some experiments with pig, and at the end of the experiments they give us the skin. And this is the reason because we cannot use pig skin from farm or for other, because in the meat industry the pig skin is burned in order to remove the hair, and in this process the brain barrier of the skin is removed. If we perform the studies with this skin, probably 90% of the drug in both cases are able to penetrate to the skin. But this is not a real situation.
Right. Curious.
Sorry.
Oh no, it's quite interesting just to know this interesting fact. So I just would like to know if there is any other question from the audience. If not, we are just we just congratulate you for this interesting lecture. So we hope all the best in the future. Hopefully, maybe in the next year you are in a very big facility, so it means that the company is growing more and more. So it will be great. And why not? Maybe some of these pharma companies are trying to get liposomes from the company. So why not? Who knows? So just thank you for staying with us in this Translate and Explain of lectures supported by the Cátedra SAMCA de Nanotecnología. And please, we will welcome just to stay in contact if you need our help, or if someone else want to contact to Daniel for any collaboration or whatever, it will be great. So thank you.
Thank you all for the invitation. It was a pleasure for me to show you the company and the technology. It will be a pleasure as well to collaborate with you in the future in different terms. We have here different students from other masters, national and international masters. Of course, this year is a little complicated because of the situation, but always we have here at least 2 or 3 students from other masters. So we will be happy to help you in this sense, and of course we will be happy to collaborate with you in other scientific projects or whatever. So thank you very much for your attention, and all of you have I think that my contact details in order to, if they need something or they have other questions, I will be happy to help you.
Thank you, Daniel.
Okay, thank you.
Thank you.
Bye-bye.
Bye. Bye.